we're going to look at least two different styles. Well, just two, because more than that takes a while. Different styles of factoring. So again, they've given us a relationship. It's not an equation. It's not equal to anything. They just want it shown in a different way. And this would be considered more of a standard form. You have a term plus some term plus some term. And we want it to be factoring. We want some kind of products involved. We want some numbers that multiply to build the same equation here, or same relationship. Usually you want to look for common factoring to start. Okay? Just because this one's a bit convoluted. I got a variable c here and another variable of f. So I've got two variables in here, which gets a little tricky to factor. I don't have the same variable through all three, so I can't common factor that out. I can, however, common factor out the number 3. Number 3 exists in all of these. I can take a 3, and a 3. In fact, I could take a negative 3 if I want my first value to be positive, which is common. Or I could rearrange these because I have two of them that are squared. So it's up to you if you want a negative or not. I'm going to factor out the negative 3 so we keep it in the same order. So this is equal to negative 3, which is our common factor. And then, well, what's negative 1 divide negative 3? That's 7f squared. Okay. Positive 39 divide negative 3. That gives us negative 13fc. And then positive 6 divide negative 3 gives us negative 2c squared. Okay, at least I've broken it down to smaller numeric values. Our coefficients are smaller. Now what? You're used to product sum. So product and sum. So in a product sum, you're looking for two numbers that multiply to a times c. So in other words, I need to relate this to my standard form. My standard form has some coefficient and some variable, usually squared. Okay? Plus some other coefficient with a variable again. Okay? This is a quadratic one. And then some other constant. We usually call it c. Now in this one, we have an extra version. We have an extra variable. It's still going to pan out. I could make the argument that there could be a y here and a y squared, and this will all work out, same thing. Okay, but what's my a value? So I'm going to say, in this case, instead of just the coefficients, because that's what we're used to seeing for a quadratic, I'm going to make the argument that we actually really what we're looking for is the first term times the last term, so or third term, we're going to say. Okay, so this is the first term, and this is the third term. So we're looking for two numbers that equal the first term, which is 7f squared times negative 2c squared. So this is a little more convoluted. We're not used to using the variable in there. And the reason being is in the quadratic, we know we can just look at coefficients and constants. But this one's not quite quadratic. This is a different relationship. It's multidimensional. There's more variables to it. So what are those when we multiply? Well, that would be 7 times negative 2 gives me negative 14 f squared c squared. Ooh, that might prove to be challenging. Let's take a look. In the product and sum, this part still stays the same, but instead of just the b term, which we're used to seeing, a number that adds up to the b term, really looking for is the second term. So what's our second term? In this case, we're looking for two numbers that add up to negative 13fc. There's a bit of a relationship here. There's an fc, and then there's an f squared and a c squared. I can build those variables. Actually, very quickly, I know that if I do, I need both of these to be an f and a c in order to get a coefficient of 13. I don't know what number I'm going to add, but I know I need an fc and an fc. Okay? Which works out great because if I have an fc times an fc, an f times f is f squared, c times c is c squared. So I'm going to end up with those values. Now I can just focus on the coefficient piece. Negative 4 and negative 13. Negative 14. Good. For a second I was going to go, that's not possible. I need two numbers that multiply to negative 14 and, oh shoot, I should have wrote it up here, FC and FC. I don't need it there. And they add to negative 13. That's actually not that bad. Negative 14 multiplied, well, I can do 1 and 14. And 1 and 14 get me pretty close to 13 as long as one of them is negative. If the 14 is negative, that gives me negative 13. And if the 14 is negative here, that gives me negative 14 fc squared. So I just found my two terms. They happen to be, and I'll rewrite them again, 1 fc and negative 14 fc. a little tricky to find in the product and sum version. That I would argue that was challenging. That was a bit of mental math. From here, the process is about the same for product and sum. We get the original, we rewrite it, get -3, and then we still have our first term, which is 7f squared. But what we're going to do is we're going to break into these two terms now. So our second term is now plus 1fc minus 14fc. And then we still have our final term, which is the same, which is our -2c squared. It's all in brackets. We then break this into pairs and we common factor. Okay. So when we common factor, well, what can come out of 7f squared and 1fc? Well, f comes out. I know that. And common factors of 1 and 7 is just 1. 1's the only one. So 1fc. So I'm just going to write it as an f. We don't need the 1. So 1's the common factor of the first two terms. And then when we divide, we get one of the f's drop off. So it's just 7f. And then 1fc divide 1f, well, we're just left with c. So 7f plus c. Let's see if that works out. And then our second terms, I need two numbers, stuff that comes out. I got -14fc and -2. Well, c definitely comes out of both. I only got one f. -14 and 2, I can take a negative out, and I can take 2 out. 2 is a common factor of both of those. So -2c is our common factor. And what do we have left in our brackets? Well, -14 divide -2, those turn into a 7. So it's 7. And then c and c cancel out, and we get f. -2c divide -2c squared divide -2c. 2's drop off, and we get a single c, so plus c. And if we look, I'm going to put a square bracket here. It might be a little hard to see, but I'll highlight it. This bracket is the same as this bracket.
Yeah.
Which means we're now down to our final product and sum piece. We can get into -3. We can just write this as a single bracket, 7f plus c. And then our other bracket is going to be whatever's left over, which is our f minus 2c. So we've now factored this. I argue that this is a hard style to factor. Yeah. It also took me a while. It's a long one. Thank you.
I would say I understand how to
Yeah.
what you do put that stuff.
The algorithm you were followed because you've seen it before, but I mean, tricky. I'm going to show you another style of factoring. I think this will be easier. I left it to second, which might be hard to follow since this is so long now. But let's rewrite it again. It was -21 f squared minus 39 fc plus 39 fc plus 6c, right? Okay. We used to call this fearless factoring. I got no idea why. But we're going to call it this. And instead, we're going to set this up easily. What we're going to do here is I'm going to look for the factors of the first term, and I'm going to write them in columns, all of the potential ones. So I have f squared, so I know I'm going to write two numbers, and f has to be a part of both of them, whatever the heck they are. Well, I have values of 21. What are factors of 21? Well, there's 1 in 21. So 1f, 21f, that's one column. I could also have 7f and 3f. Okay, that's another column. Now, technically, I have to apply that negative somewhere in here, but I'm just going to play around with that piece. I'm more focused on like the absolute values that will get me here. There's no other factors of 21. 3, 1, 3, 7, 21. That's it. Then I'm going to look for the factors of just the last term. Okay, 6. Well, same idea. I have a c. C times c will get me c squared. Factors of 6. Well, there's 1 and 6. And there's 2 and 3. Those are the other ones. Now, technically, both could be negative. Both could be positive. I'm not going to worry about that. What I am going to do eventually is they all need to add up to this middle term, 39fc. Okay. What I'm going to do is I'm going to try this first column. I'm going to multiply it by numbers in this column and then in this one. And if I don't get something that works, I cross this column out, okay, as potential factors. So let's take a look at this. I'm going to try 7f times 1c. That gives me 7fc. Okay. And then I'm going to try 3f times 6c. That gives me 18fc. 7 and 18. And now the only thing is one of these has to be negative because I had a negative 21. So I could say negative 7, and it gives me that. Or if the 3 was negative. Either way, none of these are getting to 39.
Yeah.
Okay, so that kind of quickly, if I do some mental math, I go, that didn't really work out for me. But I can try crisscross. What about 7 times 6 or 3 times 1? This gives me 3FC, and this gives me, what are those, 42? 42FC. And again, one of these has to be negative to make this a negative 21. Let's try the negative 7 to start. Negative 7 times positive 6 would give me negative 42. Negative 42 plus 3 gives me negative 39. So I'm close. I probably have the negative on the wrong one. Let's put the negative to the 3 here. Negative 3 times that gives me negative 3. Negative 3FC plus 42FC. That gives me 39. I've actually just solved it. I got kind of lucky. There are a couple more options. So it turns out this and this are the answer. Oh. So I can right away just put this into 2 brackets. These will be the first terms in the bracket. There's going to be a 7F and there's going to be a negative 3F. These will be the following terms in the brackets. The only trick here is I can't put the numbers I multiplied by each other in the same bracket. So 7F and 6C can't go in the same bracket. So since 7F is here, positive 6C's got to go in this bracket. And because negative 3F is here, and I multiplied it by 1C, it has to go into this bracket. That's it. That's the factored one. Now you might say, that's a little different from what we had down here, but it's actually very, very close. The only thing I didn't do is, remember I did common factoring. If I take a look at this bracket here, I can common factor out a 3.
Yeah.
I can common factor out that 3. So in the end, if I common factor 3 out of that, or negative 3, however you want to see it, we can take 3 out, and we're left with 7F plus C. And then the other number is negative F, what did I take out? Plus 2C. And that's it. That's the exact same thing as the other one. This version, a little more mental math, a lot less writing in the algebra to organize. And this can be done with the regular factoring too. It's even a little simpler because you don't have to write your variables in when you do that version. Okay? A lot though. That's definitely a difficult factoring question.